Hello and welcome everybody. My name is Karim. I am a first year PhD student at the University of Edinburgh. I will be presenting a preliminary design of an operating system to improve the programming of heterogeneous systems in the data center. My work is mainly motivated by the increasingly heterogeneous nature of modern systems. In a typical modern server, alongside the traditional storage and networking devices, there are now massively parallel GPUs and smart devices such as smart NICs equipped with their own memories and caches, but also multi-core ARM processors that can run real Linux programs. As a real-world example, we can find the Broadcom Stingray and the NVIDIA Bluefield DPU, which are equipped with multi-core ARM processors and various networking function accelerators. They serve a lot in a data center, especially in the context of virtualization, where the bridging and routing functionality of the VMs can be offloaded to the smart NICs. On the other spectrum, we have the NVIDIA Imper architecture, which now provides isolation between GPU kernels. So basically, now every GPU kernel has its own peer tables and caches and compute cores. As we can see, the architecture is forcibly becoming decentralized, with functionalities traditionally reserved for the CPU are now being incorporated into the surrounding devices. However, programming is still done in a traditional CPU-centric fashion, which results in tremendous inefficiencies but also programming difficulties. Due to time constraints, I will not be able to cite all of them, but as an example, every transaction between two devices must go through system memory and host CPU, but all devices are smart enough to do this by themselves, right? And we also have to write multiple independent programs compiled to different target architectures, and probably using different ecosystems. And then those programs need to somehow communicate and synchronize their actions. And this is currently done in a completely arbitrary fashion. Our main idea is to extend the process concept to heterogeneous instruction set architectures and support the usual means of process synchronization. So, for example, fixes must be enabled across instruction sets in such an OS. Such an end goal requires a flexibly designed distributed shared memory to support a unified address space for processes. And because those devices have different memory models and consistency requirements, the distributed shared memory must support multiple policies, with some regions the address space shared with replication semantics, others following right replication semantics, but it should also support non-DSMable regions. The system must support peer-to-peer DMA transactions, and it should also be able to dynamically decide the DSM policy for of a region based on access efficiency. So thank you for watching, and thanks for your questions.